Yeah, my PowerPoint. And all right, should we start now?
Yeah, go for it. Good luck.
Cool, thank you. All right. Thanks, everyone. Hello, good day, wherever you're from around the world. Welcome to my session. My topic today is how we can fast track your microservice deployment to Azure, leveraging some of the great features Azure DevOps has and the integrations and plugins. I've been enjoying all the great sessions over the last couple of days at Automation Summit in February 2022, and thanks for hosters and our sponsors. All right, before I get started, let me ask you guys a question. Have you ever experienced that your production application is on fire all of a sudden? You might have an enterprise application deployed in production environment has been running smoothly over the last, 2-3 weeks, until you made a decision that you want to deploy a new feature or a bug fixes onto the production. And if your pipeline runs, it deploys the change to your production environment smoothly. However, all of a sudden, it's on fire. Your service is not responding, there's throttled request, etc., etc. Although we might have a bunch of tests that we've done beforehand, however, since code is written by human and there's always a possibility that we can make mistakes, so your production is now on fire. And as a consequence, the developers may be forced to wake up no matter where they are, or maybe they're in a different time zone, but they're forced to wake up at 2 a.m. and jump into the production environment to fix it, and it destroys your night. And not just that, to debug in production is really risky. It's like trying to fix your airplane flying high up in 10,000 feet in the sky, and it's dangerous, risky. And you might want to say, can I reboot my system? It should fix the problem. Well, rebooting your system or your app service plan on Azure or your VM, etc., no matter whichever hosting environment that is, rebooting is sometimes can fix the problem. It release the memory, clear the cache, etc. However, sometimes some problem, if there's a bug which triggers an infinite loop or it's just some data mismatching things, then on the flip side, it might burn your entire house. So if you have ever experienced this scenario before, you might have a thought that how we can avoid these scenarios from happening upfront. So in my today's talk, I'm going to show you what is BlueGreen deployment strategy and how we can apply this strategy to deploy our microservice solutions onto Azure. A little bit about myself. I'm Patrick. I'm a solution architect at SSW. SSW is a Microsoft partner, and we do consultancies, and we offer, we design and deliver solutions for our clients across different industry. I also see myself as a full stack engineer and public speaker. Here's my Twitter. If you want to be a bit more formal, here's my LinkedIn. You're welcome to connect me. And here's my employee profile on SSW website. You can look it up on Google. And as other developers, I like to follow some great open source projects and contribute to some of them in my spare time. My recent interest has been leading an open source project which builds a conversational AI chatbot. We use Microsoft bot framework Composer and Louis. And this chatbot can serve as a virtual receptionist, so that any guest visiting your company, when they come to the lobby or the main reception desk, they can chat with a virtual bot, and they can query for employees based on their skill sets and availability, so that they can know who and when they can meet up with somebody. This can make the life of human reception much easier. So if you have similar interests, come to my GitHub and check out my activity. And also, here's my blog. I share my opinions, the lessons I've learned in my recent projects on it. If you like my post, give me a thumb up. Now, here is today's agenda. First of all, let's have a very quick overview of what microservice is and why we want to use microservice architecture against monolith architecture and how it can help to solve some of the problems that if anything goes wrong in production, why microservices tend to mitigate or avoid the disaster that can cause the entire system to malfunction or to be not responding. And then we want to focus on the DevOps side of it. I call it MicroOps. It's essentially DevOps for microservice. And what is the blue-green deployment strategy and how and why we want to use it and how we use it. And then we're going to narrow down on DevOps, on Azure DevOps, and we want to build up our build and release pipeline on Azure to fulfill this blue-green deployment journey. And I've also prepared a demo. All right, first of all, as a very high level, microservice is great. It's not just about a software architecture, but it's also a development methodology, by which I mean, if we follow microservice architecture, we can decouple the concern. We can chop the holistic business domain, which may be a very gigantic piece of knowledge we need to learn, into smaller pieces. Of course, in order to divide that to logical groups, which all make sense, it requires a lot of domain and industry experience. However, once that's been defined, developers of each microservice team can look into one small piece of the entire application so that they can have a fast developer onboarding process and less knowledge transferring overhead. And so that's why for a lot of legacy and huge enterprise application, when they start to migrate to a latest and greatest tech stack, they tend to migrate to microservice architecture following the strength fit pattern. Here is a good example in Lego bricks. So for instance, if in a traditional monolith application, if anything goes wrong with this block, if we want to fix, maybe it's corrupted or for whatever reason, we need to fix it. If we consider the old system like a 4-level pyramid, what we need to do at least is that we need to take these 2 layers off and replace or fix this block and then put these 2 layers back. Whereas in the modern microservice architecture, if anything goes wrong, I can easily fix this block. I can, take this red block out at max, and we fix it, and we can redeploy this microservice, and everything's done. And this diagram also shows us how we migrate a monolith enterprise application into a microservice components. We can break them down, regroup them into logical units, and deploy them as separated microservices. Okay, so the key components of microservices usually contains the following elements. Usually it has, excuse me, let me get rid of this pen. All right. It looks better. So usually we want a external facing API gateway, which serves as the unified facade that external consumers talk with at a single entry point. And not just that, the API gateway can serve as a coordinator that distributes or navigates traffic into the subsequent services. And also the services behind the API gateway can be protected, and because the traffic, the communication among the services can sit on the backbone network. For instance, if we choose Azure, we can use VNet to protect the subsequent services, and we only expose our APIs via an API gateway. And the subsequent services can be containerized. And containerizing the application is very important because once a developer has developed some feature and tested it working on the local machine, if you choose to containerize your application, most likely it's going to work properly on a production environment. And cross-service communication should more or less be done using some event-driven pattern. And so with that, we require some messaging system. On Azure, we have a service bus or event hub that can help us to achieve it. And most of the time, we want to enable feature flagging or toggle on and off so that we can dark launch some features to get some early feedback. Now, here is just an overview of the microservice architecture, and that's not my today's focus. Our today's focus is, of course, DevOps. So we've understood what is microservice, and microservice is essentially a bunch of services that we want to deploy onto a cloud or a production environment. So the keys to a successful DevOps journey start from containerization. And also we want to have a lot of testings, and not just unit testing at function level, but also integration test, load test, performance test, and etc. So we want to do the test, but we also want to get a good test report out from our test so that developers can jump in and fix the problems or to enhance the feature, and by increasing the code coverage so that we can have a better product in terms of the quality and code coverage. Then we talk about deployment. In the deployment area, we want to ensure that each service is independent. What this means is that the deployment of a single service should not interfere with the deployment of other services. For instance, if service 1 failed to be deployed, service 2 shouldn't be affected at all. And also, we want to have a dark launch so that we can launch some features without a major version bumping up or a very lengthy release note to tell we need to take a system down for 3 hours to deploy a major version. We don't want to do that in the modern software. We want to launch some features and get some early feedback from users so that we can improve it. And most importantly, we like to roll back when the exception happens. So when your production is on fire, we want to, as quick as possible, roll it back to a version that was running before. And if it can be a turnkey configuration to roll it back, that's great. All right, so we've understand the key point of DevOps journey. Then I would like to show you guys what is BlueGreen deployment and how it solves some of the problems we mentioned in the previous slides. So basically, it's a rollout strategy. What it does is that it can reduce the impact of the interruptions caused due to the bugs or the issues you have in the new version. And then it then certainly supports instant rollback on production. How does it support it? Basically, what it does is you have an application running in your production environment. It's currently on state 0, and we can see that you might have a bunch of instances running running your application, running different parts of your application. And state 0 means that at this point, all the traffic are navigated to these these blue instances. And apparently, we only have blue instances at this state. However, when we've now developed a new feature, instead of rolling it out to all instances, what we do instead is we deploy to a small portion of the instances that's running in production environment. And these are the green deployment. So they are green doesn't mean that they work automatically. There could be exceptions or bugs. So these green slots can be red. If there's anything wrong, what we do is that we jump in and fix it. But the benefit of this strategy is that even if anything goes wrong, it is only affect a small portion of the users rather than the entire system, or rather than the entire user base. And if everything goes well, we want to roll more users over to this green slot from the blue. It's an arrow, sorry, from the blue slot. And finally, we want to roll every single user over to the new version. So this way, we complete a deployment of a new version without giving user a surprise. But we slowly and gradually roll user over to the final state that we expect. Like cutting sausages, people wouldn't be aware if anything, unless there's a very serious issue and we roll too many users in one go. Unless that happens, users tend to slowly onboard with the new version. And that way, we will have a happy deployment journey and happy user feedback. So we've now understood the principle of a blue-green deployment. How can we do it on Azure? There are basically two approaches. First of all is to leverage Traffic Manager with your applications. And for instance, you might have a bunch of VMs, and a group of them are your blue VMs, and you might have another group, which is the green VM. And Traffic Manager can work together with your load balancer to navigate the external traffic to the VM sets which is required to, and so that we gradually transform users from the blue VMs onto the green VMs. The other one is the one that I like most, which is app service deployment slot. What it does is, for every single app service we deploy, no matter it's the traditional app service or the containerized app service or app service running on containers, it has a feature called deployment slot. And we can deploy a lot of slots, and we can easily swap between them and configure the distribution of traffic into different slots. And I'll show you the details in my demo. So in comparison, to compare these two strategies, we can see that the principles are similar, basically. What the Traffic Manager does is it has the Traffic Manager is a abstraction of your traffic navigation, your traffic distribution and navigation service, whereas the other one is a simplified version that Azure handles it for you. Basically, it provisions two hosts for you, and it can distribute traffic among the staging host or the main host. Okay, so next up, we've understood what we want to do. Then let's get hands dirty, how we can do it. We want to build our pipeline using DevOps. We want to have a build pipeline, and within which we want to run our unit test, and we also want to publish our test coverage report so that we can have a fast feedback, at least for developers to jump in and react if anything goes wrong. If some change I made break some existing test, what I should do, I should come and fix it without proceeding to the next step and deploy to production and realize that the green deployment, even the green deployments are all red. And at last, if everything goes well, we want to publish the artifact so that our release pipeline can pick it up and deploy it to Azure. All right. So once we've got the artifacts we want to release to Azure, so we want to use Docker to containerize our application. So we want to build and properly tag our images, and we want to push it to some container registry. And in Azure's world, we want to use Azure's container registry, which has a default built in to other Azure services, and those authentication can all be done via managed identity. I also show you that in my demo. And then we can do our green slot deployment, and we can, or QA or a small portion of users can jump on to the staging or the green slot to do some tests and play with it. Once they're happy, we can do a slot swap, or we can, like one of the diagrams I showed earlier, we can gradually migrate users across from the green slot onto the blue slot. Those can all be done with turnkey configuration, which is nice and easy. All right, so enough talking. Let's get hands dirty and jump onto the demo. So before I show you anything on Azure or anything graphical, I'd like to show you the infrastructure as code. As a DevOps guy, we want to keep our infrastructure as code as much as we can. And I'm using Bicep Template. I'm not going to drill down too much into Bicep, but basically, Bicep is a superset of ALM template, and it offers a great programming interface. And when I'm writing Bicep templates, I'm nice and easy and quick, and all my knowledge about the ALM templates that I had before can all work here. They're interchangeable. And Bicep are built into a ALM template, so I would suggest you use it. And there's a nice extension on VS Code called Bicep Visualizer. So once we've built, let me make this bigger. So once we've made our Bicep template, what we can see is we'll have a very, very direct visualized way of showing how our resources are like, if they are provisioned on Azure, and what's the relationship between them. As we can see on this demo, we have an app service plan, we have an app insight, and we have a bunch of services. We might have an API gateway, which is an app service, and alternatively, we can use some other API gateway service offered by Azure, such as API management. And we have a bunch of other services. And they all ingest their application logs into the app insights. And app insights can integrate with Log Analytic Workspace, which was a new feature released, I think, over the last 20 months or so. And within the Log Analytic Workspace, you can write some nice and cool store queries to find out what happened with your applications and retrospectively review the logs. Now, let me jack this across and do a side-by-side comparison. So our web app has each of the web app has its own corresponding staging slot. What that means is that a web app can be served as the blue slot, where it handles most of the traffic in a production environment. And whenever we release a new version, we always release to the green slot, which we can also call it staging. But mind you, this staging is not like a traditional staging environment where only your QA or your testing or your developers jump in and play. But this is essentially a mirror of your production environment. And we gradually migrate users across from the staging environment onto the from the production environment, which is the blue slot, onto the green slot. And this is something you might notice that there is a role assignment. So we need role assignment so that we can be authentic. The web app can be authenticated to pull images down from the container registry. And Azure has some built-in roles. So you might see a magic grid here. Is essentially the owner roles grid. You can find it out by running a simple Azure CLI to find out the built-in roles, which I'll show you in a bit. What this role is actually means. So, but apart from that, they are pretty identical. If we look at the definition of a web app, it looks like this. Basically, we reference an image from the container registry, and it has system assigned identity and runs on the app service plan as a Linux container app. And we want to use the managed identity so that we don't need to supply the username the admin username and password to have access to our container registry. If we come back and we look at the slots, the definition is very similar. They're pretty much like identical. The difference is though that it has a different naming with a slash and the flag that identified that it's a corresponding slot rather than the main app. You might point it to different tags of the image, which I'll show you how we achieve it on DevOps pipelines. Okay, so once we've done our infrastructure as code, we've done our templates, we run AZ deploy, then on Azure, we are gonna get a bunch of services provisioned. And a good thing about the Azure resource group is that we can see all the deployments that it's done over the last whatever the retention period is. And you can see the details like who triggered it and what it does, whether it succeed or failure. And let's take a look at one of the services. For instance, this API gateway. This is the main API gateway. Interesting. By the way, that's an extension where it can blur out the subscription ID. Apparently, it's not working. But anyway, it doesn't matter. It's my MPN account. So what this API gateway does is that we have a deployment. We have an application deployed to it, and it's serving all the traffic as the blue deployment. And let's have a look. It's currently sitting at V2 and just dumping some basic information. And within this web app, there is a deployment slot configuration where we currently route 100% of the traffic to the main production instance. We are routing 0% of the traffic to the staging environment. And you can see we can easily swap it, but we're not going to do it manually. We're going to do it via DevOps. So if you take a look at the staging slot, what it does is it's serving a different version. And imagine if your production is on fire, you want to quickly roll back. What you can do is you can swap, or you can do it here. You can easily swap the production version and the staging version, so it rolls back to the version that worked before. This is nice and cool. And the other thing I want to show you is the deployment center. So as we can see, as I mentioned before, we use the managed identity that's controlled by our Bicep template. And we want to have access to one of the container registry to pull the images across. And apparently, you can choose some other container registries. You don't have to choose Azure Container Registry, but they all work similarly. And I love to have all my application built on native Azure services. All right, so we've done that. We can start writing some code and making some change. So if we look at the code, first of all, when you develop, let's create a new version. Let's see what the version is actually sitting at right now. So we are sitting at version 1 for the staging instance and version 2. Now let's just bump it up to version 3. Hello everyone, and we'll do something. We'll keep the rest the same. And usually, as a developer, what you're going to do once you've developed a version, you're going to do you're not going to do release immediately. You're going to do .NET run. Yeah, and then you're gonna do some checking on a local machine, and it says hello everyone. It's very friendly, which is good. Now the next step is, since we are containerizing our application, we want to build a Docker image and test it locally, just to make sure that everything works as expected. So I do have a Docker file in this directory, which I'll show you in a bit, but I'm gonna build it first. Docker build. Let's give it a tag. V3 test with retest. And once we build it, I have the Docker extension installed, so we can see a new image has been built. You can apparently, give them a different tag to the same image name, and then we want to run it. Let's just kill the existing ones first, and we can run this one. Run it. Apparently, you can do this by entering the command as well, which does the same thing. Let's open the browser. We can see. Oh, it's still showing as V2. That's not great. Oh, because that's how I built my Docker image. There are different ways you can build a Docker image. You can, at bare minimum, you can do it as what I did here. We copy the published artifact into our container, and then we spin it up. Or you can have the build process all added onto your Docker file, so that it does the build process and then spin up and then containerize it and spin up the application. But there's a reason why I like this way of doing things, especially when we consider running the test along the process of the build process, and we want to publish the test result onto Azure DevOps. But for now, for the time being, since I've copied from the publish folder, so let's publish it. So let's do .NET publish in the release mode. All right, that's done. Nice and cool. Let's build it again. Let's give it another tag, maybe just 2. Give it another tag, and let's see how it does this time. Let's kill this one, remove. Now we have a new tag here a few seconds ago. Let's run it. And we open the browser. All right, so V3. Cool, it's working. All right, so in theory, if we've done the DevOps story properly, whatever works locally should work properly on cloud. So what we want to do is we want to commit our change. Want to commit, say upgrade gateway to V3 and press enter, and then we want to do git sync. All right, now let's jump on to our DevOps pipeline, and what we can see is that since I've configured the pipeline to run on the branch trigger with the pass filter, so it's triggered automatically. So what it does is it builds up the application. It does .NET restore and do a .NET publish, as what we did locally on my console, on the built-in console on my Visual Studio Code, and it publish and then copy Docker file and publish the artifacts. Now you might wonder, if I want to do a test, how I can do it. So I've prepared another example that I run on my another service, which does the test. So the way we do the test is simple and easy. Let me just edit pipeline so that we see the details. First of all, what we do, we check out the code, of course, and we install the SDK. And we run a test in the release config. And here, the keyword here is the collect coverage. And we want to define the output format to a recognizable format, and easy to pass that to a report types in HTML. In order to do that, we need to have a report generator tool, and we can install that via .NET 2 install. And once we've installed it, it will generate. We need to point out where the report is, and then we convert it to some nice parsed HTML. Once that's done, we can publish the code coverage result to Azure DevOps pipeline. And then after that, we can publish and do whatever we need to do to publish the artifact. So if we have a look at one of the build runs that I had before, it has the code coverage. So it shows that how much coverage I've achieved and how many lines I've covered. I've covered the hello world line. I've covered the say hello method. So if we come back to the code and have a look at the test I've written, what you'll notice is that whatever assemblies that your test is referencing, in my case, it's referencing the main service logic. It's gonna be covered on the report. So if the tech lead or any other developers on the team are not so happy about the change you've made because you've broken too many tests, they will potentially reject your PR if we've hooked up this build pipeline to your PR process. And also all these criteria can be automated so that your PR get automatically rejected if you haven't met a certain acceptable coverage rate. So that's how we do testing and how we publish the test report in Kubernetes format onto Azure Pipeline. That's a cool feature DevOps offered. So if we come back to our main API gateway run, apparently it's the build has done. The end results is a Docker file with the released bin folder with all the artifacts, which are all a bunch of DLLs and your app settings and etc. Now, if we come to the release, I build a release pipeline. What it does is it's deploy. It's very simple. The first step, what it does is that it's gonna build and publish the Docker image onto the container registry. Apparently, we need to configure a container registry service connection beforehand. It can be done in the project settings. And then I give it a tag name. I like to use the build number as the tag name. And you can pass additional environment variables if you need to. Once we've built the image, all we need to do is very simple. We just need to tell our web app, hey, web app, you need to point to this image with this tag. Then the web app is gonna pull over the image and recycle the application so that the staging slot, we choose to deploy to slot. The staging slot is going to run on this new image. And this new image is v3. Now, let's jump onto the staging slot. So this is the main app. And if we look at the staging slot, we can come here. It's been blurred out for a second. All right, so I think I have this open here. Staging. All right, and let's refresh. Oh, boom, it's done. We're on v3, and currently the traffic is still 100, which means that nobody on the public will access the staging instance, because most likely we are going to configure the custom domains pointing to the main app. And your C records and etc. all configured, and your SSL and etc. will all be pointed to your main app. However, if you change the portion of the traffic, you can slowly distribute some users onto your green slot, and gradually you can move all users from the blue slot to the green slot. Now, once you are happy, the other approach is once you can get your QA team jumping onto the staging environment to exercise and run their test cases. Once they're happy, you can swap the slot as well. So if we jump back to our release pipeline, and we can see in the most recent release, we have a swap stage. What it does is actually it's very simple. Azure DevOps has these commands which can help us to swap the slot upon an app service easily. If you want to have a look at the YAML definition, it's essentially the Azure App Service Manage task. And what we are doing is that we are swapping the slots, and we give it a name. We pick up which slots we want to swap. We want to pick staging as the source slot, and we want to swap with production. And And then if it's loaded successfully, the blue slot will become the green slot, and the green slot will become the blue slot. All right, let's approve it. Oh, and by the way, we can, if we look at the edits panel, we can build up all sorts of different approval process or triggers, or even the gates with more advanced, configurations here. And in our case, I just set it up a very simple approval process, and I enabled self-approval, and I just hit approve. So what it does is, let's have a look at the log, see what it's doing. Any questions so far? Doesn't look like so. So basically, it swapped the slot of the main site and the staging slot. So if it's done properly, as our understanding, we should see the main app to sit on v3 and the staging sits on v2, because essentially they swapped. Let's just give it some time. So the benefits of this strategy is that apparently we can have a flexible deployment and swapping feature, but something we need to watch out for is to achieve a seamless swapping experience, we want to make sure that the staging slot and the production slot, or the blue slot and the green slot, all talk to the same data store. And if you have EF Core or some other ORM that has some database migration process, you want to make sure that whatever database schema you've changed on one of the slots does not affect the other slot. So this strategy, this deployment strategy can work very well with API versioning and the dark launch strategy, which is not gonna, for the interest of time, I'm not gonna cover that. And in the future, if there are other community events, I'm happy to talk about that and expand on that in details. So now we've done the slot swapping, and let's come to the app end. So we have this one, which is the staging site. Let's refresh it. Boom. It's now sit on v2, which is an old version, and the main site is now on v3. All right. So we've done a seamless swap, and all the users are rolled to the new version with the new features, and we have happy customers. No system will be on fire because we've tested thoroughly on the real production environment, talking the same database, and that is great. And that's the end of the demo. And let's jump back to my slides and see what we've covered. So as a summary, in my today's talk, we've had a very quick overview of what is microservice and why we want to do microservice for a modern application, and why it can help us to solve some of the problem. If any service goes wrong, we can just simply turn it off in production or roll it back. That wouldn't affect other parts of the system, and you can scale that particular service by itself rather than have a holistic scaling strategy. Oh, sorry. Just give me a sec. My slides stopped responding. Stop. Share again. Oh, sorry. My apologies. For some reason, my slides just stopped responding. let me quit my slide and, oh, we jump to the, anyway, we are coming to the end of my presentation anyway. So we've covered the the blue-green deployment strategy and how we can implement it on Azure DevOps, and how with that strategy, how we can minimize the impact on the production environment when we deploy a new version of our software. With that, thank you very much. Any other questions? Any questions? Hello?
Hello, I don't think we've got any questions. That was a really good session. Thank you.
Oh, my apologies that my PowerPoint just for some reason is stuck.
Okay, take your time. I mean, if you can get it back online, would be great. No.
Yeah. Let me try to. It's just a few slides with the references and etc. All right, let me try to launch it again. Yeah, I want to have a good ending. My apologies. Let me share screen again. It's the last few slides. All right, let's get back to here. Yeah, so we've covered the, and we've also covered the DevOps process, and I've showed you guys how we can implement the blue-green deployment strategy on DevOps, and I've done the demo. And here are some references. I can see a question. Can I share your project Bicep? Oh, that's a very good question. Actually, this project on the microservice template is public. I'm gonna send a link here, just in case. Let me do a test on the incognito. Yeah, so you can see you can see all the files and all the project board. I want to build a template so that everyone from the community can use it as a starting point to build your microservice. And I added a few commands there, a few instructions there, and the commands you need to run. And one thing I found is that for those of you who use the Mac running on the Apple Silicon, you might notice that the image you build on your machine works, but it doesn't work on Azure. The app service log doesn't tell you very clearly what's wrong. But actually, what I found was that you need to use Docker buildx to build it on the underlying chip architecture. But you won't have this problem if you build your image on pipeline, because you choose which agent you want to build your image on. So that's not a problem. It's just an interesting issue I met. Is DevOps and DevSecOps are same? I don't think so. Although I'm not an expert in DevSecOps, but I think DevOps is a greater. It has a greater range of domain rather than DevSecOps focus on the security side of things. But to be honest, I'm not an expert on DevSecOps. I do have some experience in data DevOps, Data Factory, Synapse, and etc. So these days, automation is everywhere. What I believe is that in the future, whatever we can automate, even the creation of your Synapse workspace, your Databricks, can all be, whatever can be automated should all be automated. Hope that answers your question, or part answers your question, Ahmed. The next up, as that says, hi Patrick, blue-green deploy is only for Microservice. No, it's not. It's not. It's also for the monoliths. But as what I said, it works very well with microservice architecture. For instance, if any single service goes wrong, we can roll it back without affecting other parts of the system. Your entire system will still work. And maybe, for instance, take finance application as an example. your payment module might not be working, and you can roll it back to old version, which still work, but your customer management or your bank transfer module will still work and function as is. The new patches you've applied can still work. So it works well with Microservice Architecture. Whereas for monolith one, we can roll the entire system back, but then you have to start from beginning again. Jasper, how would the green-blue deployment work using a container orchestrator like AKS? Oh, that's a very good question, actually. And that actually refers to some of the cool text that Yas showed in his talk. I think it's all about how we manage the deployment of the pods, basically. And yeah, I haven't dived into this area. I'm happy to find out what are the good tools that we can use. Because in AKS, it has its own tool set. For instance, if you want to talk about scaling, it's different from how Azure handles the scaling for us for web app. In AKS, there's a Kida and all sorts of other tools that we can use. I'm pretty sure there's some tools in AKS that we can use. But your cluster has its own ingress controller. I think that's either use Ninja's ingress controller or Azure application gateway. I think that's the starting point. How we can hook that up with the different underlying pods is where we need to look into. And to be honest, I don't know what is the out-of-box solution there. I'd like to dive into that area as well. So maybe we can learn together. Any other questions? And if you have any questions after this, you are most welcome to connect me on my social media. Let me just. These are my social media links. Is there a list of
for you?
Deploy? Sorry?
I think there's one more question for you around the deployment Azure patterns. Is there a list of deployment Azure patterns somewhere?
Azure Architecture Center has a repository of documents about the architecture that are on Azure, but I don't think there's a specific topic about deployment pattern. So what I usually refer to is Azure Architecture Center. I don't think it has a subset of deployment strategy. Maybe it's just a way of, categorizing things. Yeah, there's DevOps, but I don't think there's something specific for deployment. But I'm happy to dig further and see if I'm missing something. All right, no problem. Thank you, Jasper. Thanks. And hopefully you guys are gonna like it. And I apologize for the last bit of the technical issue. It happens when on live demo. For some reason, the PowerPoint just stopped responding. I wish I have a version I can roll back. I have another PowerPoint instance that I can drag across instantly. Maybe there is a way. All right.
Any more questions from anyone? Any final questions before we wrap up the session? Really good feedback for this session. Again, thank you, Patrick, for showing us the patterns. I think it's really good to see all the strategies that you can actually use to kind of avoid and minimize disruption to the users, and which allows you to kind of move quickly with your deployments, but take that into consideration. Really good strategies today. So thank you very much for joining us today.
Thank you.
So yeah, let me stop the recording as well.
Sure.
All right.